All right, 6.7 inverse relations and functions. I'm going to get into a couple of things here and then show you a couple of things on Delta Math. So, sorry, my font here is a little messed up when I zoom in on it, so it looks a little bit nasty. But so inverse, and again, we've been dealing with inverse operations the entire year. The inverse of addition is subtraction, inverse of multiplication, division, inverse of the square root is squaring something, inverse of the cubing something would be taking the cube root of it. So we're going to get into inverse functions. So if a relation pairs element A of its domain to element B of its range, so if you have an ordered pair, its inverse, you just flip them. The x value becomes the y value becomes the x value. Okay, if both the relation and its inverse happen to be functions, they're inverse functions. And if they're inverse functions, they're considered what we call one-to-one. Okay, so those would be what we call one-to-one functions if both the original function and its inverse is indeed a function. And how do we tell if something is a function? We did the vertical line test. So there's a couple problems where you have to do the vertical line test. Well, to tell if its inverse is a function, you do what's called the horizontal line test. And I'm going to show you just a couple of examples of that on Delta Math as we move forward here. But first type of example is looking at a relation. And again, a relation is just a set of ordered pairs. Given an x and a y, you literally just flip the ordered pairs to show its inverse. So the inverse relation is just flipping each one. Okay, so the original relation S is 0, -1. The inverse of relation S would be -1, 0. Okay, sometimes you're going to see an inverse written like this, and I want to make sure that I show this notation. This is the same thing as the inverse of S. So you'll see a lot of S inverse. This does not mean S to the negative first power. This means S inverse. And with relations, we're just, again, flipping the ordered pairs. So I'm going to show you a couple of examples with that on Delta Math towards the actually, you know what, let's go ahead and do that right now. Okay, so we go into Delta, we take a look at the vertical and horizontal line test, and it's saying determine whether the following graph represents a function. So again, a one-to-one function means it passes both the vertical line test and the horizontal line test. Okay, one-to-one means it passes the vertical and horizontal. A function means it passes the vertical but not the horizontal. So you can see here on this problem, if I draw a horizontal line, it's going to touch at 3 different places. Okay, so again, if I were to, draw, oh darn it, okay, I can't do it here at home. But if I were to draw a horizontal line, it's going to touch at, again, if I draw a horizontal line, like you can see here at -3, 1, 2, and 3 different places. So that is not, its inverse is not a function. Therefore, it's not a one-to-one function, but it is a function because it passes the vertical line test. And so again, when you submit, you'll see that it runs, a vertical line test and showing that it only hits once, and also a horizontal line test, and it's showing that it hits at 1, 2, 3 different points. Okay. So again, doing a new problem like this, okay, yes, this passes the vertical line test. It doesn't hit it and it passes the horizontal line test. So this would be a one-to-one function because it passes both the vertical line test and the horizontal line test. Okay, so going back to that, the other type of problem, and this one can be a little bit challenging. Oh, I took these off. I'm going to take these ones off. I don't want those. Yes, I want to remove that skill. These ones right here. Okay. So this is saying click the graph to make a point. So what we have to do is we have to make 5 different points. And remember, so I'm going to label like these points, but I'm going to use the inverse of each of these points. So this ordered pair right here would be 1, -3. Well, I'm going to click -3, 1. Right? That's the inverse, is we just flip the x and the y. This would be 0, -2. So I'm going to click -2, 0. This is -4 or 0, -4. I'm going to click -4, 0. Then we can go to another point. This is -3, -1. So I can go, right, -3, -1. So I can go -1, -3. And then this right here is -3, -5. So I can go -5, -3. So to make its inverse, we've got to just pick ordered pairs that are on the graph and then flip them and turn the x's into y's and the y's into x's. And you can see as you submit the answer here, it shows that it's right. So again, they're showing it in a table, and you can write them down if you want. I'll show you one more of those. I'm going to show you one that's a line, different grade. There we go. Okay, so again, this would be the ordered pair 4, 0. Well, we need to go to 0, 4. This is the ordered pair right here of 1, 1. Well, the inverse of 1, 1 is 1, 1. This is the ordered pair 7, -1. So I need to go to -1, 7. And I think it makes me do 5 points. So this is -5, 3. So I need to go to 3, -5. It's going to make me do one more. But you see the idea of how these become inverses. Let's see, what's a good point here? How about right there? -2. 2 would be 2 and -2. That's the inverse of the given line. Again, just flipping the x and y values from the giving values. So those problems you should be able to do after seeing a couple of examples. Now we get into the algebra part of it. And into the algebra part of it, really, we're going to use a ton of stuff that we've used before. So to find an inverse, we need to, so to find the inverse, we're going to switch x and y. Like we're physically, literally going to replace anywhere there's an x, we're going to put an x. Anywhere there's a y, we're going to put a y. Okay, so that would be step 1. And then step 2 is we're going to solve for y. That is my inverse. Okay. So I'm going to, step 1, switch x and y. So I'm going to have x equals y squared minus 1. Now, how would I get y by itself? I'm going to add 1 to both sides. That gives me x plus 1 equals y squared. Now I'm going to take the square root of both sides. When I take the square root of something being squared, it just disappears. When I take the square root of x plus 1, it stays x plus 1. But don't forget, whenever you square root both sides, your answer becomes plus or minus. So this right here is the inverse of this problem. Okay, so again, we switch x and y, and then we're going to use inverse operations to get y by itself. So I got a few examples here from Delta Math, a little bit challenging problems. And again, here's this notation. So you're going to see this. So if I write this, this is the same thing as a y, right? So I'm going to rewrite this as x equals y to the 7th over 3 plus 4. And now I need to get y by itself. So what do I need to do? I need to move this 4. I need to move this 3. So I'm going to move the 4 first. I'm going to subtract 4 from both sides. Gives me x minus 4 equals y to the 7th over 3. I'm going to multiply by 3. Okay, so this gives me 3 times x minus 4 equals y to the 7th. And then just like how I get rid of a square root, just how I got rid of a squared, I took the square root. I'm going to take the 7th root of both sides. So I'm going to raise it, take both sides to the 7th root. Okay, so this is the 7th root of 3 times x minus 4, and that equals y. I don't plus or minus it because the index is odd. If it was an even index, then I would. So that would be this one right here, and that would be the answer. Okay, so again, some of these towards the end get a little bit tricky. I picked a couple of harder problems just to kind of show you how to do them. So this one, again, if you wanted to rewrite this, y equals the 5th root of x over 7 plus 5, all raised to the 3rd power. So I'm going to switch my x and my y. Okay, so I got x equals the 5th root. Sorry about my dog barking. Sorry about that. Okay, 5th root of y over 7 plus 5, all raised to the 3rd power. So here, I got to get rid of this, so I'm going to cube root both sides. Okay, so I've got the cube root of x equals, and again, all that happens here is that cube cancels. So I've got the 5th root of y over 7 plus 5. I'm going to subtract 5 from both sides. So I've got the cube root of x minus 5 equals the fifth root of y over 7. Multiply both sides by 7 to get rid of the fraction. Okay, so now I've got 7 parentheses cube root of x minus 5 equals the fifth root of y. To get rid of the fifth root, I'm going to raise each side to the fifth power. And that's everything here, to the fifth power. So that's going to cancel this and give me y equals, in parentheses here, 7 times the cube root of x minus 5, all raised to the fifth power. And that would be this answer right here. And again, this is notation for the inverse, okay? Those are some difficult problems. You're going to have some that are a little bit easier, but again, we're using inverse operations. So you got to switch the x and the y, and then after you switch the x and y, you're going to solve for y using inverse operations. Again, I never took an even index, so I don't have to plus or minus this. That will be in a few problems. So give this section a shot. If you got questions, make sure you're answering. Keep up the good work. Almost done with Algebra 2.